Okay, great. Welcome, everyone. So my name is Avery Hagleitner, and I'm joined by Beth Jubera today. We're both developers on Dynamic Cubes, and we're going to give you a walkthrough of Dynamic Cubes, talking about the technology and the new features that just came out in 10.2.1.1. So, like I said, I'll start with an overview of the technology, talk about the new features and improvements that we've been making, do a demo and walkthrough of the technology. So, Dynamic Cubes. Dynamic Cubes is an extension of Dynamic Query that's in Cognos BI. Dynamic Cubes can achieve high performance analytics and reporting over large data warehouses. And we're talking large in terms of terabytes of data. We can do this because we make use of extensive in-memory caching of members, data, expressions, results, and aggregates. But it's worth noting that Dynamic Cubes doesn't bring everything into memory. It selectively caches data that are most likely to be used by users. Query performance in Dynamic Cubes is also accelerated by what we call aggregate awareness. And this aggregate awareness guarantees the routing of queries to any database aggregates or in-memory aggregates that you might have in your system. We also have some easy tooling for you to be able to optimize performance with these aggregates. We'll give you a show of that later on. So Dynamic Cubes are two major parts to it. First is the server side of Dynamic Cubes, which, as I mentioned before, uses multiple caches to improve performance. All the members are loaded up front, which results in fast member traversal in the studios. As well as the cube data is cached once and shared amongst all users. This is the best use of memory in the cube. And since Dynamic Cubes is an extension of Dynamic Query and built into Cognos BI, it is managed through Cognos Administration Console and also available through the Cognos SDK. Modeling, there's a new tool called Cognos Cube Designer, which is designed to support the best practices and performance of modeling your cubes. There is support for calculated members and measures, relative time, custom aggregations, as well as time-state rollups. Also in the Cube Designer, you have the ability to model in your in-database summary tables so that the engine knows where the database aggregates and can guarantee routing to those tables. New features that just came out in one of the new releases is the ability to write Cognos SDK commands to do some modeling, to create your model. Okay, so I'm going to talk quickly about the life cycle of Dynamic Cube. So starting with your warehouse and your data in a star or snowflake schema, this Cube Designer tool to model and publish your cube. You would publish the cube definition out to the content store. Then you would go into Cognos Administration, where you would manage the running instance of the cube, start it up, which would then start up that running instance of the cube inside the Dynamic Cube server, which is running within the query service. And then users can go into any of the studios, whether it be Cognos Workspace Advanced, Report Studio, Analysis Studio, to do the reporting and analytics against the cube, as well as any other information that's out there in the system. And then finally, you might want to optimize the cube for performance. And using Dynamic Query Analyzer, the tool to look at query performance, you can run the Aggregate Advisor, which is the tool that I mentioned earlier, to recommend aggregates. As I mentioned, Dynamic Cubes achieves fast performance through its extensive use of in-memory caching elements. Sometimes you might hear Dynamic Cubes be called an in-memory rollup engine. I want to emphasize the R in rollup for relational, meaning that Dynamic Cubes are really just cube definitions that maintain an active connection to the underlying database at all times to get the data that it doesn't have yet cached. So with that, it goes to show that with the better optimized your underlying warehouse is, the better performance any of those initial queries that we run to get those values will be. So I'm just going to talk a little bit about the various caching elements that we do have in the cube. First is the member cache. When you start a cube, all the dimensional metadata members are loaded into memory. This makes exploring the metadata tree in the studios very fast because it's all right there in memory. It also helps during query execution because we don't need to hit the database for member information during query time. So The action that I mentioned before about going to your Cognos administration to running instance of the cube, this is the first thing that happens. All your metadata information is loaded into memory, into the member cache. Once that's loaded, your cube is considered running. It's available for users to start querying against it. The next cache that loads is the in-memory aggregate cache. The aggregate cache contains in-memory aggregates, and these are similar to database aggregates in that they hold aggregated values for specific slices of data that roll up from either database aggregates that you have in your system or the underlying fact table in your warehouse. But a little difference, since all this aggregate data is in memory, queries that can leverage aggregate cache return almost instantly. One thing to note is that the in-memory aggregates load in parallel in the background after the cube is started, and as each in-memory aggregate is done loading, it's available for users to query against. We also have a query data cache. When users run queries against the cube, the engine first figures out what data values it needs to calculate the answers. If the values aren't found in the data cache, then the engine looks into the aggregate cache to see if the values can be rolled up from there. If so, cool. We've avoided a trip to the database and can answer the queries solely based on what's in our caches. And for any data values that aren't in the caches yet, we issue some simple SQL database or the summary tables and then cache them here in the data cache. Expression cache used in the engine, where we use to save and reuse evaluations of certain expressions. Typically, these expressions are filter type expressions that filter down from a large set down to a much smaller set. So, for example, think of top count, where you're getting the top 10 customers out of millions of customers. So that evaluation is stored in the expression cache. And last but not least is our result set cache. When a report is run, the report results are saved for later reuse here in the result set cache. So if you were to run the same report again, or if someone else runs the same report again, you'll get the fastest response time possible because you get the values or the results that it has in the result set cache and does not have to go and process the report inside the engine. This next slide is just another view of all the different caches, but with security in mind here. Security is processed at a higher level, so it's not actually built inside of each of the caches, so that the caches can be shared across all users. So other solutions out there, they might store the caches with security. That's not the case here with Dynamic Cubes. Having shared caches allows for optimizations where we might prefetch some data and keep it in the caches. And really, we find this is a better use of memory in the caches. But, with a solid security solution, users only really get the members and data that they are allowed to see. So this next slide is kind of based off of the last slide, but it's going to go through a little animation of of the cache population when you're starting the cube, as I mentioned earlier, as well as what it would look like, the flow through the engine when you're running an initial query. So you start up your cube. What first happens is the engine issues SQL to obtain the member information and load up the member cache. So at this point, the cube is up and running. It's ready to go, ready for queries to come in. At that point, as I mentioned, if you have any in-memory aggregates defined, they will be loaded in the background in parallel. And SQL queries will be issued against the underlying, get that aggregate data to fill that in-memory aggregate cache. Okay? So, let's say initial query comes in. First goes to the DQ query processor and checks the result set cache. Do I have the results from this query in my result set cache? Nope, it's not there. So, it then passes that request along to the MDX engine. And the MDX engine first checks the member cache to get an idea of what dimensional members are involved in the query. Once it has that information, it then determines what data values it needs to calculate the results for the report. And then that query comes back down to the dynamic queue, check the data cache, do I have the values that I need? In this case, since it is an initial query, no it doesn't. Then it searches in the aggregate cache in kind of a waterfall method, data cache, aggregate cache, to see if it has the values that it needs. If it does have values that it can get and roll up, it will then roll up those values and populate the data cache there. And if that's all you need, great, and everything will be returned. But let's say, for the sake of argument, that you need some more values that aren't in the in-memory aggregate cache yet. In that case, we will issue simple SQL down to the fact table and possibly the summary database aggregate tables to get that additional information, and then we'll end up caching that here in the data cache. Now that we have everything that we need, we pass those values back up to the MDX engine to do some processing. It might store some information into the expression cache, and that result, prior to returning the full result back to the user, we'll store that result in the result set cache. Let's say you run the same query again. It goes through the query processor, checks the result set cache. Yes, I have the value in there. I will return up that query really fast. Let's say you run a third query and it comes through and it's not in the result set cache. What ends up happening is the same flow through the MDX engine to get the member information, checks the expression cache to see if it has what it needs. If it doesn't, again, goes through the data cache. Same flow that I showed you before. Does it have what I need in the data cache? Cool, if so, I'm done. If not, that's fine. Let's go look in the in-memory aggregate cache for the information, might roll up some values, and I'm just going to fly through these. It's the same flow as I showed you before. If it needs to, it will go to the database to get the values. If not, it'll just get all the values that it needs from the caches. And I just want to re-emphasize here that dynamic cubes is just really a dimensional in-memory cache of a subset of the values that are in your warehouse that is star snowflake schema. It does not store all the detailed fact values, and it does not pre-aggregate all the values that are in the database. It's really a beefed-up cache for cubing. But it does provide very fast query performance because of the caches, as well as our in-memory aggregates and our aggregate awareness, where we can guarantee routing to any database aggregates that you do have. Now, you may be wondering, how do I get these aggregates that I talk about that improve performance? Well, you run the Aggregate Advisor. This is available in the Dynamic Query Analyzer tool, and what the Aggregate Advisor does is it reviews the cube model, as well as optionally you can specify a workload that contains actual usage queries, which in detail really it's the measures and the levels that are involved in queries that are actually run by users as input for the advisor to determine what in-memory and database recommendations to give you. So when you run the Aggregate Advisor, you have the ability to pick and choose which reports, packages, users, or busy times you want to optimize for your aggregates. And this flexibility really allows you to focus on improving performance for actual user queries that are run in the system. So let's say you asked the advisor to give you in-memory aggregates, and all you really need to do to apply to make these in-memory aggregates live is save them to the content store. And so the next time you restart your cube, they will be loaded after loading the member cache. And this is really the easiest way to get aggregates to improve query performance. So if you also ask for database aggregates, the Aggregate Advisor will provide database aggregate recommendations, which you then give your DBA. And once those tables are created in your warehouse, you'd model in what we call aggregate cubes into the Cube Designer and republish the model out to the content store so that when you restart your cube, at that point, the cube knows of those database aggregates that the engine can try to guarantee routing to. One thing to note is throughout this whole step by getting aggregates, there's no report reauthoring required here. The reports can still remain, going against the package or goes against the cube. You don't have to, rewrite your reports to go against specific aggregate tables or so forth. So now, virtual cube. Virtual cubes is basically a logical cube that is defined in terms of exactly two cubes. Here in this example, we have what we're going to call base cubes in color blue. At the bottom here, we have a store sales and a web sales cube. And since store sales and web sales have nearly identical dimensions. We can easily merge that into a virtual cube here in green called sales. And you can merge two base cubes. You can merge a base cube and a virtual cube. You can even merge two virtual cubes together. In this example here, we're merging the sales virtual cube with yet another base cube called inventory into a inventory sales virtual cube. And all you really need in common between the two cubes to be able to merge them is at least one common dimension. And in most cases, time is a common dimension to merge upon. So there's several use cases for virtual cubes. One is, as shown here, is bringing together multiple fact tables into a single cube for reporting. Another one is for achieving lower latency for new fact data. Here we have two base cubes. The idea behind this use case is that you split your fact table. One is historic data, much smaller, and is updated more frequently. So any queries that come in at the top, at the all sales virtual cube level, query performance is greatly improved and latency is reduced because your historic cube, because it's updated less frequently, let's say monthly, you can keep the data cache, the in-memory aggregates, the database aggregates, all up and running and just as they are, warm and ready to go. And with the recent cube being much smaller and having much faster refresh times, can be refreshed more often, maybe even nightly. And if you do have a query that comes in and you want to run it against the entire time span, since queries that come into the virtual cube do get split amongst the underlying base cubes, queries against the historic cube are really fast because all your data is cached and ready to go, and the query against the smaller recent sales cube is also fast because it's a lot smaller. Now, if you have a query against the virtual cube that only really targets the current month of data, that performance is also improved because that query just goes against a smaller fact table and smaller set of information. Okay, so I'm going to take a quick the questions on the board. A question from Jason. How and when are caches expired? So the member cache does not have any expiration. It's loaded up front, fully loaded, ready to go. The BI administrator has the option to refresh the member cache at will with a Cognos administration action. The in-memory aggregate cache does not have any expiration. It's also just loaded, ready to go, as well as the data cache. There is an option in Cognos administration to refresh the data cache at will. So you can choose, as the BI administrator, you can choose to invoke these cache refresh commands or schedule them as you'd like. Now, you do have the ability to specify cube properties, meaning memory to set aside for your data cache. And once the data cache hits a certain threshold, I believe it's 80%, the cube cache will go through some maintenance and throw out the least recently used information in the caches. Another question from Nigel. Why would one be forced to merge pairs versus sets of cubes at a time? It's currently a limitation of dynamic cubes to merge exactly two cubes at one time. There's no restriction on how many levels of merging you want to have. So in this example, we have 2 levels of merging virtual cubes.
And this is Beth. I just wanted to say that store sales and web sales might be from very similar database schemas, but they're looking at different fact tables. You have your store fact table and your web sales fact table. And the sales virtual cube is a way to view both in one.
All right, follow-up question about the caches. So the cache can be days, weeks out of sync with the actual data, or even between different aggregates in the same cube. So you bring up a good point about cache consistency with the underlying warehouse, underlying warehouse data. Now, what we recommend to customers, and what we actually have seen in many IT shops, is that they do have a maintenance window, whether it be nightly or 2 days or weekly, where they would not make any updates to the warehouse data during the day while the cube is up and running and queries are going against it. But when they do have new data that they want to ETL into their warehouse, they would do it during their maintenance window, stop any user queries that are going against the cube, bring the cube offline, update your warehouse tables, update your database aggregates, restart the cube. The cube will have an empty cache, so and then be ready for queries to go with the new data. All right, so going back to our slides here. So I mentioned the Cube Designer. This is the new modeling tool. So on the left-hand side here is a data source explorer that has the active connection to the underlying database to show you the tables, columns, and other database artifacts for you to use when modeling. In the middle here is the Project Explorer, which shows you your cube, your dimensions, hierarchies, and levels. On the right-hand side, we have the Object Editor, which gives you a more detailed view of what specific object you might be modeling. In this case, it's showing level. And at the bottom right-hand corner, we have the Properties and Issues area, where you have even more fine-grained information, properties, and so forth. There are two types of Issues tabs. One is modeling issues, errors to resolve before publishing your cube, as well as a performance issues tab, which I'll talk about in a little later. One thing that I will mention about the Cube Designer is that it does have an auto-generate feature, which if we have time, hopefully we'll get to show you a little bit of that, which use some smart metadata to auto-generate or get you up and running with the cube model as fast as possible. It'll take a look at the existing relationships in the database between the fact and dimension tables, as well as do some data sampling if you choose to do that option to kind of auto-generate the cube model for you. In the Cube Designer, there's also a quick publish ability. This will accelerate publishing of your cubes and deploying and administering your cubes when you're in development phase. So you have the ability or the option to create a package here from this wizard. Create a package for your cube for users to query against. You have the option to add the cube to a default dispatcher. Now, if you wanted to add your cube to any other dispatcher other than the default, you'd have to go through the Cognos administration portal or use the SDK. You also have the option to start the cube after adding it to the default dispatcher. And you have the option to set the logged-in user account that's used to route the sign-on access to the underlying data source. Let's see. So I'm going to quickly go through the security workflow here for applying or defining security on your cube. First thing you would do in Cube Designer is you would define security filters, whether to grant or deny certain parts of your cube. You would take those filters and put them together into security views. Publish that new cube model with your security views and filters to the content store. And then finally go to the Cognos administration to associate those security views with your users and groups or roles. Okay. So that's kind of the overview of the technology of Dynamic Cube. Now I'm going to highlight a few of the new features that just come out this past year with version 10.2.1. So we have improved security. Previously in version 10.2, which came out last September, just the member security. Now we have the ability to define security based on a lookup table that might be in the customer's warehouse already. Several customers already have lookup tables or security tables that they join to, and this ability allows them to do that with Dynamic Cube. You're also allowed to now secure dimensions, so you can secure a whole dimension, take it out of your cube for certain users. You have the ability to secure attributes. One example of this is you might have an employee dimension, and you might want to hide the social security number attribute for certain members of the dimension. Also enhanced security refresh, meaning if there are no changes to your actual model, but only security definition changes. You can accelerate the refresh of your information by just refreshing the security metadata and not the entire cube, and not having to stop and drop all the caches that you have already warmed up. This is generate cubes and dimensions using data sampling. That's an enhancement to the auto-generate feature of Cube Designer to help you get up and running as fast as possible. The Performance Issues tab in Cube Designer, this is a list of warnings of potential things that it sees in the model that might violate best practices in terms of performance. These are things such as maybe you might have used a string column instead of an integer column for your level keys, where we know having integer columns is best for performance. Just warning you about some potential areas that you might want to take a second look at when modeling. Also, time state aggregation rules. This is mainly used in the inventory type of cubes. We now support first, last, and current period semi-aggregation rules. Also, there is centralized administration. In the Cognos Administration Status tab, there is a new Data Stores view, which shows you all your Dynamic Cubes data sources, and it's really a one-stop shop for anything that you need to do with Dynamic Cubes. Previously, you would find your Dynamic Cubes under, you would manage your Dynamic Cubes under System, and then drill down through the dispatcher and the query service and so forth. This new data stores view is a more streamlined view of that same information and same actions that you can perform. There are also aggregate advisor improvements. You get better recommendations, and as well as query engine performance improvements, as well as memory ones. So for Fixpack 1, which just got released this past September, you now have the ability to model measure folders and sorting. So if you have a lot of measures, you can organize them in folders and control how they are presented in the studios. There's also improvements made in the Cube Designer for Expression Builder to make it easier to do some copy and paste in the Expression Builder. The Quick Publish wizard now has the ability to publish to public folders. Prior to this, your packages would be published to my folders, so being able to publish to public folders is really cool. Also, you'll see improvements in DQA and Aggregate Advisor. You'll see a kind of a facelift in DQA where Aggregate Advisor is the main thing you'll see in DQA, as well as you'll be able to pick and choose and select specific in-memory aggregates you want to apply to your cube. Prior to this release, you would have to have applied the entire set of in-memory recommendations. With Fixpack 1, you can pick and choose which one you want to include. With Fixpack 1 and also with 10.2.1, there is a significantly reduced memory cache footprint. We're always improving our performance and our memory consumption. You have the ability to specify dimension filters. So you can specify a filter expression to narrow down the members that are in a dimension. For example, you might have 100 years in your time dimension, but maybe your data and maybe what you want to report against is only the last 5 years. You can specify a filter expression on the time dimension to only focus and only load those 5 specific years in your time dimension. There's also support for macros in the expressions in the expression builder, and the release of the modeling SDK, which is really helpful for business partners and customers who want to accelerate the creation of their cube model through programmatic ways. Here's just a visual of the memory improvements we've been making over the past 2 releases. We've almost cut it in half. Pretty awesome. Pretty awesome stuff. And the last thing I'll mention here is IBM Business Intelligence Pattern with Blue Acceleration. And this was just announced a couple weeks ago at IOD. The BI pattern with Blue Acceleration, it really just takes the fastest BI technology and combines it with the fastest DB2 technology and puts into a customized deployment that's already pre-configured. So it takes Cognos BI, which is really, mainly dynamic cubes, as well as DB2 with Blue Acceleration, and focused on high-speed analysis for large data volumes. And this is available for customers to deploy in their peer systems, private cloud, sort of appliance. The last slide I'll go through right now is cube technology. So I've talked about dynamic cubes, and you might already be familiar with other lab technologies that we have in Cognos. It really depends on what your application objective and your data sizes really are that drive what technology you go with. So if you need write-back or what-if analysis, TM1, that's what you go with. If you want high-performance analytics, then you have large data volumes and your warehouse is in a star Snowflake schema, dynamic cubes fits the bill. Now if you want consistent performance on your transactional operational system, Power Cubes continues to be the choice there. Or if you want to get up and running really fast in a smaller data set and you want to control the latency, controlling the caches, we recommend you dimensionally modeled relational or DMR. Okay. So let me go back to the web conference to see if there's any questions. I have a question here. How are changes to hierarchy structures over time handled? For example, hierarchy for historic sales might be different from today's hierarchy. I'm interpreting this as possibly a modeling question, meaning today you might have modeled your hierarchy with certain levels and so forth, but you might later on find you might want to insert another level, or the levels aren't quite right. Enrico, if so, really, if you want to change the model in any way, add levels, add attributes, add measures, what have you, you'd go into Cube Designer, make those changes, republish your cube, and restart it. And at that point, the new cube model is read up, the member caches are loaded, and that's up and running. Now, whether or not that affects your report is a different story. So once you publish the new cube model out to the content store, the running instance of the cube is still going against what the previous version of the model. So everything, for the running instance of the cube, it uses what it has in memory at that point. It's only when you stop the cube and restart it that it rereads the model information from the content store. So any of your modeling changes won't be in effect until you stop and restart your cube. Next question, are there any examples of dynamic cubes in distributed samples? If you mean the Cognos BI sample, like the Go Sales Data Warehouse that's out there, yes. Yes, there are. It's out there. Look for it in the sample.
So this is Beth. I'm going to open up a VM, and we're going to do just a quick live demo. That's always dangerous, but of the different components, the different tools used for dynamic cubes.
Beth, Avery, the name of that dynamic cube in the product samples, do you happen to know it off the top of your head? Okay.
I think it's under the web content samples, and I believe there's a dynamic cubes folder under there.
Great, thank you.
And along with that, there is a Cube Designer model file out there, as well as the deployment that has the relational information that you might need as part of that.
So here I have Cube Designer, and the first step to Cube Designer is you need to know what your relational data source that you're going to define your model on top of. So I selected have to log on again. So this tool is based on, underlying all of it it's common to Framework Manager, if you're familiar with Framework Manager. However, this is a redesigned, brand new tool for cubes, for dynamic cubes. So everything in here is specifically geared towards modeling dynamic cubes. Very drag and drop, very simple to use. So in here, I just have a connection to the underlying relational data sources that I could use as a source for my dynamic cube. You would select a schema that you want to model against.
Incidentally, this is based off of the sample.
Yes, so the Go Sales DW, these are all part of the sample databases that come with BI. So now that I've selected the schema I'm interested in, I can see on the left side here the live connection to the underlying database. So under here I have my historic sales fact table that I would be using. And we actually have the ability, since it's a live connection, you can view the data live here. I'm actually going to, so what I'm going to do instead is I'm going to open up an existing model. And let's so in here I've created this historic sales cube, and under historic sales I have the dimensions that I've defined. It's a simple retailer cube. So I've got my different hierarchies. Product has multiple hierarchies under the dimensions. So I have product classification, product color, product size. I can double click on product classification. I can see the levels that I have defined. If I was to double click on one of these products, I would see the caption and the levels keys, how we uniquely define them. I can look at the measures that I have defined that were all pulled out of created from the relational values here. Now, if we had gone through the aggregate workflow, which I'll take you through as well, we can also model or register those summary tables that we've created in the Cube Designer. So here I have the aggregate table or the summary table that we might already have in our system. I could register that and guarantee routing for whatever slice or slices of the cube this aggregate table covers. I can also create calculated measures. I can create filters on the dimension table. I can define those time state roll-ups we discussed earlier. We can view we get a little ER diagram of our system that's been defined. This is where you can define relative time support and all sorts of other good things. Now again, this is just for modeling dynamic cubes, so we don't get distracted by other options or other features. It's just for modeling dynamic cubes. So once the dynamic cube has been modeled, you can go ahead and publish, and Avery showed a screen capture of this earlier, where you have the options to do some administration here for a quick, get you up and running without having to go through administration. But since administration is how you have to administer cubes is a little new for dynamic cubes and different than other providers, we have this new feature, or a new tab under the status and Cognos administration, for those of you at the data stores tab. Under the data stores tab, you'll see all the dynamic cubes that you might have deployed. And once a dynamic cube has been deployed, you can add it to the data store, the server groups that you choose. And you can also drill in. So I'm looking at my historic sales cube. In here I have the administrative actions, which are also available through the SDK, to have activities like starting, stopping, refreshing those caches that we had discussed earlier. You also have the ability to set and view properties of a dynamic cube. This is things like setting those cache sizes on all those beautiful caches we have, enabling the workload logging, and which captures the generated that we can use an aggregate advisor to make the in-database and in-memory recommendations. So there's a number of cube properties that can be set here. Also at this level we have a metrics panel, which has a lot of information about the runtime stats on the cube. So things like what percentage of your caches are used, what are your table hit rates on those aggregate tables that you've defined? Are we able to route to them? The number of requests you've had, the number of members loaded, when the last time the cube was started. All sorts of interesting facts. I also wanted to call out Dynamic Cubes is just another provider. So in any of the studios, it's going to just look like another provider. There's nothing new in terms of or creating reports or using the studios. Just that things should come back faster when you run the reports. Okay, so I also wanted to show what else is new, and maybe you're not familiar with, is Dynamic Query Analyzer, which is where you run the aggregate advisor, which generates in-memory and in-database recommendations. So here's Dynamic Query Analyzer, and we see previous results that we may have run for a workflow. So pretty simple. This is a very simple tool. There's been a lot to make this kind of the big green "It's so easy" button. So all you do is you select the cube you want to generate those recommendations for. And you have the option of using a query workload that we've been capturing as you maybe run reports. Or we can just look at a cube structure. But we do a lot of row sampling and table sampling. A lot of smarts went into these recommendations. We make recommendations on how much it reduces the rows that are aggregated on and how often they're used. So we're going to look at query workload. You can also set how large you want these recommendations to be and how long you want the aggregate advisor to run for. So once if you specify you want to analyze the workload, then you can you have options to specify how you want that workload to be used. So if you have certain reports that you're more interested in than others, if you have certain users, maybe with a better title than others, that you want their reports to come back, if you want Monday morning reports to come back faster, you can specify those values or how you want to view them here. So I'm going to run finish, and it's running in the background. It's not running in the background. You have the option to run in the background. I should just take a second. Okay, so that's going to run in the background. But in the meantime, to show you what a result would look like, a previous result would be you get this kind of a snapshot of what it recommended. In this case, we had 1 in-database recommendation and 4 in-memory recommendations. And as part of the recommendation, it tells you what slice of the cube that recommended. So within memory recommendations, you have the option of applying the in-memory recommendations that you're interested in. Now, these just get stored to the content store, and we say, these are the slices of the cube I want in my in-memory aggregate, and when the cube restarts, we will load those in-memory aggregates at cube startup. Now, for the in-database recommendations, we give you a textual file with a description of those in-database recommendations. Now, this would be a starting point for whoever ran the aggregate advisor to go back to their DBA and say, this is the in-database aggregate or summary table that was recommended to make my dynamic cube run faster. Let's get this into our warehouse. And usually a DBA will have some sort of, they might be able to look at this and figure out how it best works into their ETL process. So this isn't the actual DDL for generating the summary table, but it does give you a very nice start, and it also gives you a clean representation of what is in the table versus the cube model, so that you can easily go back in once that table has been created and model it within Cube Designer, as I had shown earlier. So that's it, a simple one-click save the in-memory aggregates, and then you can take this database, the in-database, and go back to your DBA for further discussion. So then once the in-memory aggregates and the in-database aggregates are there, no change to your reports needed. They should just start running faster. Yeah. So that was a very quick walkthrough of the aggregate advisor and a quick view of the Cube Designer.
No questions here, and I don't see any other questions online either.